let's go ahead and get started here. Trust you did well on your test. Class in here, for the most part, did a fantastic job. And a challenging test. Exam will have a lot more variety to it, which actually works in your favor because that means fewer fractions and fewer radicals. Okay, but that test is coming up. The exam is coming up in lesson 44, which, for those of you in here, that's Tuesday the 12th. If you're watching on YouTube, it's the video will be uploaded on Tuesday the 12th. But anyway, whenever you end up taking that. Next section of notes. I mentioned yesterday, I can't remember if it was on camera or off camera, that this next section we're starting, must have been off camera because yesterday I didn't record much, is one of my favorite sections because to me it's easier and frankly it's just more fun. Messing with fractions and all those picky little details, I just don't like it. But I love solving equations, right? It's like a puzzle. You're trying to figure out this one unknown value. And so that's what we're going to be talking about next. And this will, of course, continue after the exam even. But if you want to get that term in your notes, equations. Equations. And equations are algebraic expressions with equal signs. Algebraic expressions with equal signs. That's the key to an equation. If there's an equal sign in it, it's an equation. If there's not an equal sign in it, it's not an equation. Now there are three types of equations. The first type of equation is something we call a conditional equation. A conditional equation. This is what most of the equations that we will work will be. Okay? We're used to these where you solve and you get an answer for x, right? For instance, if I have 5x plus 2 is equal to 3. All right, well, if I wanted to solve for the x, going back in your mind to Algebra 1, I want to start by getting rid of the positive 2. We said we can move it over, but when it moves over, it becomes a negative 2, right? As we change sides of the equal sign, we change signs. A quick review from Algebra 1 rather, leaving us with 5x is equal to 1. By the way, if you did not have me for Algebra 1, I should preface this. Normally we put a negative 2 on both sides to cancel the 2 away. I say move it over, it becomes a negative 2. It's the same thing mathematically. One's just easier to think through when we get to certain types of equations. All right, and then to finish solving for the x, we'd have to divide away the 5 from both sides. And we end up with x is equal to a fifth. What this is a condition under which this statement is true. It is only true that 5x plus 2 can equal 3 if x is a fifth. Does it make sense why it's called a conditional equation? Kind of like maybe if you're like, hey mom, I'm going to go to this activity or whatever. It says under the condition that you clean your room first, Brandon. Anyway, she asked me to mention that specific. Just kidding, she didn't ask me. But the condition, right? You have to meet this condition or this requirement. Well, this is a condition under which the equation is true. Again, this is most of the equations we work. But there are a couple other types of equations. For instance, you learned in Algebra 1 about something called an identity. We'll talk a lot about different identities in pre-calculus next year for some of you, a couple of years from now for a few more of you. An identity is an equation that is always true. There are no wrong answers. An equation is, or identity rather, is an equation that is always true. For instance, if I had 3x negative 8 is equal to 2 times x negative 4 plus x, without giving me something too crazy hard, because otherwise I'll make you all do it on your calculator, give me some number. Genesis? 3. 3 times 3, class? 9 minus 8? 1. Or 3 minus 4, class, would be negative 1 times 2. Negative 2 plus 3 is... So evidently x can be 3. But Maddie might give me another answer. 4. All right, 3 times 4, class. 12 minus 8 is 4. All right, what's 4 minus 4? 0. 2 times 0, of course. 0 plus 4? 4. There are no wrong answers. So what we would do for an identity, if you write this in your notes, is for our x, we'll say that x is equal to all real numbers. And you might remember this from Algebra 1. It's an R with 2 vertical sticks on it instead of just the 1. It just means all real numbers. Because mathematicians were too lazy to keep writing out all real numbers. They made up a symbol for it. That's what I love about being a mathematician. There's not a way to be lazy, make one up. All right? And how would we spot an identity, though? Well, for solving any equation, right, we're going to start by distributing the 2 here to get 3x minus 8 equals, class?
2x
plus the x. Of course, we need to combine like terms here to get 3x minus 8 is equal to 3x minus 8. Well, question. When would 3x minus 8 equal 3x minus 8? Always. Under what condition is it true? It's always true. When is Abby behaving the same as Abby? Always. When does Abby look like Abby? Always been in the morning. Just kidding. Anyway, you get the idea. It is what it is, right? And you might also recall when we worked in Algebra 1, I said if you've got something on one side of the equal sign and you got the same thing on the other side, just knock it off, right? Well, I got a 3x over here and a 3x over here. Let's just knock those off. I've got a negative 8 over here. I've got a negative 8 over there. Knock them off. And what's left now? Nothing. What's left over here? Nothing. So nothing, represented mathematically by a 0, equals nothing or 0 always. And so here's how you spot the identity if you want to write this down. When everything cancels out of an equation, you're left with an identity. Or you know it was, to begin with, an identity. If everything cancels from an equation, you have an identity. Or if the two sides match. If the two sides perfectly match, of course. That would end up resulting in everything canceling. All right, questions on the identity. The last type of equation you might have is something called a contradiction. A contradiction. This is what happens anytime somebody tries to talk to Abby. I'm just kidding. I'm making Abby out like she's this awful person. She's actually a really nice girl, just in case, watching on YouTube, you're like, who is this horrible creature? Anyway, a contradiction is an equation for which... Oh, brother agreed with me for a second. Anyway, contradiction is an equation for which there is no solution. An equation for which there is no solution. No matter what answer you give, you are wrong. This is like, well, one day, guys, when your wife's like, or when you ask your wife, where do we want to go eat? She says, I don't know, what do you want to do? And you suggest something, and it's wrong, and you suggest something else, and it's wrong. And you're like, I asked you what you want to do first, why don't you just tell me? Anyway, contradiction. Now I'm making my own wife out to be a horrible person. She's a wonderful woman. I love her to death. I also love to pick on her. Anyway, but a contradiction is an equation for which there is no solution. No matter what answer you come up with, you are wrong. Can you imagine a test full of contradiction equations? All right, but you would spot them as contradictions and you'd write no solution and you'd be correct. All right, for instance, if I wrote 3 times x plus 1 is equal to 5x minus 2 times the quantity x negative 7. Well, no matter what number you try to come up with, you're going to be wrong, but let me show you why that will happen. Of course, again, in an equation, we want to get rid of those parentheses, we want to distribute the 3 Genesis to get. And of course, over here, we want to distribute not a 2, but a negative 2, Kendall.
Negative 2x.
And of course, we want to combine like terms here to get 3x plus 3 is equal to class 3x plus 14. And, oh, remember, if something matches on both sides, you can cancel it. So the 3x's cancel, and I'm left with 3 equals 14. That is a lie, right? If I'm like, hey, Renee, how old are you? I'm 14. No, well, she's not actually 3 yet, but she's closest to 3 I've got. So, no, you're 3. I'm 14. It's the same thing. No, it's not, right? Or how much money you got? I got about $14. Hey, we could actually go get some food. Whereas if you really only have $3, well, I guess you go to the snack cart, right? Be a sponsor, right? But it's not the same thing, right? It's a lie. And when you end up with a lie, you have a contradiction. That's where you would write no solution. This is review from Algebra 1. That said, I didn't have all of you in Algebra 1. And for some of you, it's been a couple of years. Questions on these. Do we remember these from the past? The conditional, identity, and contradiction equations. Any questions? All right, now, next thing in your notes, how to solve equations. And I kind of already showed a lot of this, but how to solve equations. Next section notes, solving equations. As I showed it just a moment ago in this contradiction equation we were working, step number 1 is to get rid of parentheses. Get rid of parentheses. Parentheses get in the way of solving an equation because of what comes up in step 2. So step 1 is to get rid of parentheses. By the way, if you want to make some little sub-notes that are not on the poster, getting rid of parentheses may mean just dropping them if they're preceded by a positive, right? Or changing all the signs if they're preceded by a negative, or distributing if you have a value in front of the parentheses, or if you have 2 sets of parentheses, maybe foiling or double distributing. If you have like a binomial square, square the first, square the last, multiply and double. Oh, all those things we learned in the first test segment, right? So get rid of parentheses is step 1. So that step 2, you can combine like terms on each side. I was lazy and didn't write all of that. But I want you to write all of that. Because that's what mathematicians do. We be lazy and make extra work for others. Okay, so it said perfectionists are those who take great pains and give them to others. Anyway, combine like terms on each side. So think of the equal sign as kind of this wall that goes down the middle of the equation. On one side, combine what you can. On the other side, combine what you can, but never the twain shall meet. They are their own thing. Okay, it's like Trump has this wall built between non-America and the United States that he wants to make great again. Except Joe Biden's in office now, so I digress. Grace Christian School does not support or endorse any political candidate. All right, step number 3, once we get to that point, we're going to have a single x on one side, at most a single x on the other side, because we've combined our terms. If there's an x on both sides, we can't solve for both x's, right? So what do we have to do, Kendall, if we have a single x on one side and a single x on the other?
Get rid of the little x.
We have to get rid of the little x. And think of it, for instance, as, how many of you have younger siblings? How many of you younger siblings are annoying at times? He's staring at Abby. You put up both hands. He wasn't actually looking at you. I made that up. I like sowing discord among the brethren and the sistren. But anyway. Anyway, so, sometimes you just, life is nice and you're in your room, you're relaxing, and maybe you're diligently working on your algebra homework or, talking on the phone or texting or whatever you guys waste your time doing. And then the little sibling comes in, or maybe you're with friends or something worse. Yeah, and then the little one comes in and is like, no, get out of here, Corey. And try to hang out with my friends. You go, do puzzles or color with crayons or something, you little twerp. You would never call him a twerp, though. That would be mean. We don't advocate calling people twerps. But anyway, you got to get rid of the little one. Well, if there's an x on both sides, whichever one is the little one is the loser. And so we just get rid of it by moving it to the other side. But write this down. When it changes sides, it changes signs. When you cross Trump's wall, you change your identity. Now, if you do it legally, you legally get that legal immigrant status, and you have all the benefits of being an American, and you have a pathway to citizenship. And if you climb the wall, your identity is changed by bullets. And anyway, this got very political. Anyway, get rid of the little x. Okay, when it changes sides, it changes signs. Then finally, get x by itself. There should be only a single x left in the equation at this point. We've gotten rid of everybody else, either by combining or eliminating, moving, and so get the x by itself. The example on the poster, I'm not sure how well this shows up on YouTube, so I'll show the example on the chalkboard as well, a little bit bigger. If I can even read it, I think that's what I wrote on the poster. 5x plus 2 equals 2 times the quantity x plus 4. Again, I can't do any combining of like terms as long as there's parentheses, so I'm going to get rid of it, and here class will simply distribute to get class.
2x.
Here we go. Now, I would look on this left-hand side and say, what can I combine together? And the answer is nothing. And then I look on the other side and say, okay, what can I combine over here? And the answer is nothing. Okay, if there was something I'd combine, I would do it. If I can't, whatever. We move on. Now I see a 5x over here and a 2x over here. One of them is little, class. 2x, and we're going to move the little guy to the other side. But when it moves, what is now a positive 2x, or what is a positive 2x, becomes now a negative 2x. And that's going to give me 3x. Now, normally we would say 3x plus 2 equals 8, but I'm lazy. I don't want to write that. So what I'm going to do is I'm going to say, well, wait, if the x is coming over here, I'm going to want to get it by itself anyway, correct? This 2 is in the way. So let's move the 2 as well, and it also changes signs and would become negative 2 to get 6. And now I just solve by dividing by 3 and get x equals 2. Okay? Questions on this? We remember solving equations from Algebra 1. All right? Write this down in your notes if you would. 4x plus x plus 3 equals 2 times the quantity x plus 6. 4x plus x plus 3 equals 2 times the quantity x plus 6. What's the first thing we have to do here, Michael?
Distribute the 2.
To get?
2x plus 12.
Good. And since there's nothing to distribute on the left-hand side, I could recopy it, or I could go on to the next step, which is to do what, Audrey? Not yet. The second step,
Combine.
combine on each side. Yeah. And I can do a little combining over here. What combines?
5x.
Right, the 4x and the x to get 5x plus 3, all equal to 2x plus 12. Then what do I need to do, Brandon?
Move the 3 over.
Not yet.
You have to get rid of the 2x.
Yeah, let's get rid of the 2x, the little one, move it over and make it
Negative 2x.
negative 2x, which gives me,
3x.
and because the x came over here, that tells me I do, in fact, want to move the 3. For instance, if the x was going over to this side, I wouldn't want to move the 3, I'd want to move the 12 over, right? But since the x is over here, we will move the 3 over as a negative 3, and that'll end up giving me 3x is equal class to 9, so we divide and we get x equals 3. We could check by going back and plugging in a 3 here and a 3 here and a 3 here and seeing if it's true. I'm usually too lazy. Just be careful in your steps, and you won't have to check. You could be lazy. So get it right the first time. No need to check. It's a big waste of time, right? As long as you're careful. Now, on a quiz or test, after you finish the whole quiz or the whole test, might be good to go back and check. 2 reasons you don't want to do that until you're done with the whole thing, though. Number 1, you might run out of time. It might slow you down to check, and that's not worth it. Even if you got an answer wrong, you probably got partial credit. But number 2, if you screw up something when you work the problem, when you go back and check, you'll usually screw it up the same mistake a second time. Whereas if you've done the whole quiz, you don't exactly remember what you did on the problem. You have a better chance of not making the same mistake again and actually catching a mistake. So that's free. If you feel like you must check, the book always says check. I don't check. I'm too lazy. Questions on solving equations? All right, in your textbooks, page 65. Page 65, we're going to do numbers 2, 6, 10, 14, and 18. You're going to solve each of these equations as far as you can go. Once you've solved it, you will label it as either a conditional equation, meaning x equals something, an identity, everything cancels, so you know your answer is all real numbers, or it will identify that it's a contradiction, because the variable vanishes and you're left with a lie, in which case your answer is no solution. Thank you, Maddie. All right, so doing numbers 2, 6, 10, 14, and 18. There at your seats. Doesn't this already seem more fun than radicals? Let's be real. It's great. Some people are like, oh, talk about Trump's wall, you sound like a radical. I don't know. Banned from YouTube for spreading misinformation or something. Several people finishing up. Just take a little bit longer here. Again, if you have an actual answer, you should label it conditional. Thank you, Maddie. If you don't get any answer, it's either going to be identity or contradiction. But technically, if it's an identity, your answer is all real numbers. And if you have a contradiction, of course, your answer would have to be
No solution.
no solution. And the identity, everything cancels. So you're technically left with 0 equals 0, which is always true. In a contradiction, the variables will cancel out. You'll be left with a lie, like 5 equals 7. That's a lie. That's never true. There's no solution. All right, now let's take a look at these then. Number 2, what did you get for your answer, Maddie? X equals 29. Clearly, this is a conditional equation. Number 6, Kendall.
E equals 45.
A number 6? Genesis? Should be b equals negative 6. And so therefore it is a conditional equation. Let's look at it real quickly. We have a negative 9b, positive 10 is equal to 64. First thing I need to do here, Kendall, there's no parentheses to get rid of. There's no combining I can do. There's not even a little b to get rid of. So I've got to go all the way to step 4, and that's get the x, or the b in this case, by itself. I've got a negative 9 and I've got a 10. Which one is with the b?
Negative 9.
The negative 9. So whatever's least attached to the b, remember, is what we'll start by getting rid of. So we'll need to move over the
10 is negative.
right, and that should have given you a 54 equals negative 9b. Oh, I know what you did. And then how do we get rid of the negative 9? Divide it. Now I know what you did. You subtracted it. You probably even wrote this, but in your brain you subtracted the 9. Instead of dividing positive by negative is negative, 54 divided by 9 is 6. Okay, I see what you did now. So I was like, how did you do that? Okay, I got you now. All right, back to Kettle for Redemption, number 10. What was your answer?
This identity.
It is an identity, so your answer is...
Ax plus 10 equals ax plus 10.
Well, that's not your answer, but that's how you realize that your answer should be... When does 8x plus 10 equal 8x plus 10? Always. So your answer is...
Oh, no solution.
Oh, class, all real numbers. X equals all real numbers. It's always true, all real numbers. But it is an identity. Very good on that part. Number 14, let's go to Michael. What did you get for your answer here?
Z equals 4/5.
I did not get z equals 4/5. Audrey?
Yeah, 22 over 5.
Oh my, which would be, anyway. And what did you get, Brandon?
I put no solution.
There is a solution. It's a conditional equation.
I got z equals 2.
I got z equals 2 also. Let's see if we can figure out what we did wrong here. We've got a 2 times a 4z. Michael hates you now. 2 times 4z minus 6 equals 10 minus 3z. It's like Joseph in his dreams. There's Abby and her right answers. All right. Anyway, all right. So what we should have done first, Michael, was to distribute the 2 to get
8z negative 12.
is equal to the 10 negative 3z. Now, here's where we got to be careful. Obviously, there's no combining on the left. There's no combining on the right. So I need to go to my third step, which is to get rid of the little z in this case. But Brandon, which one's the little z?
Negative 3z.
The negative 3 is little, but when I move it over, it becomes positive 3z. And I think that's where we messed up. That's where we ended up with a 5. I got the 22/5, or in your case, the 2/5. So we end up with an 11z, not a 5z. But also, if the z is coming over to the left, then if it ain't a z, we're going to want to get rid of it anyway, right? So let's also move the negative 12, Audrey, as a positive 12. And again, that's where not 2, Michael, but 22. And then when we divide the 11 from both sides, there's our z equals 2 conditional equation. Who else had z equals 2? I just called on the wrong side of the room. All right, questions on this?
I just had a wrong problem.
All right, questions. All right, and then let's go to number 18, and let's go back to Michael for redemption. What did you get for your answer here?
No solution.
No solution. It is, in fact, a contradiction. If you distribute the 8, it'll give you an 8/3 r negative 32 equals 8/3 r negative 35. Well, 8/3 r on both sides, class, can cancel. And if negative 32 equals negative 35? No, that's a lie. No solution. This is a contradiction equation. Doesn't sound like anyone went 5 for 5, but I might be missing something. Did anyone go 5 for 5? Well, Maddie, great job. 4 for 5? Just missed one. All right, a few more of you. 3 out of 5? 1 out of 5? Just kidding. I want you to go back and do the evens we skipped. 4, 8, 12, 16. 4, 8, 12, 16. Now we've had a chance to kind of figure out what we're doing. Let's practice with a few more. You just need a minute or so to be finishing up these 4 problems. We'll take a look at them together. All right, pencils down. Let's take a look at these as well. Number 4, I do want to point something out because, again, mathematicians, lazy. We always look for the easy way to do anything. And frankly, negatives just mess up my life, okay? So here's a strategy tip. If you have a bunch of negatives in an equation, as long as you change every single sign, you can change it all. So you might want to jot down that strategy tip, and that makes life suddenly become a lot less complicated. So as we look at our steps, right, we want to get rid of parentheses. Well, there aren't any. We want to combine like terms. What like terms? We want to get rid of the little k. What k? So we just want to get k by itself. I've got a 1/3. I've got a 12. Which do I get rid of first, class?
12.
The 12, because it's less attached to the k. We move it over as a
Negative
12 to get a third k equals 2. And then how do I get rid of a 1/3? Well, it depends. If you leave it written like this, who remembers from Algebra 1 how you can get rid of a fraction and multiply by a variable?
multiplied by the reciprocal.
Multiplied by the reciprocal 3 over 1. Of course, I'd also put the 2 over 1, and both numbers, now in this case I didn't really need ones to cancel, but they would, right? And that'd give me k is equal to 2 ones times 3 ones, class, gives me 6 ones, so we're just 6. 6 first, but whatever. The other option would be, if you had this instead of 1/3 k, you might recall that you can always move a variable to the numerator, making it k over 3 equals 2. Well, since the k is being divided by 3, after all, 1/3 of something is the same thing as that thing divided by 3, you could just say times 3 that way, and still get k equals 6 either way. How many regardless got k equals 6 as the answer to this conditional equation? For number 4, or number 8, excuse me, that was number 4. For number 8, no parentheses, no combining. What's the little g here? Audrey? The 12g. So let's move the 12g over to this side by making it a... And we put a 13g and a negative 12g together, we get g. So in that case, let's take the negative 3 over here, move it over to this, excuse me, g over here. And let's take the 24 and move it over as a negative 24. So I already had a negative 3. Now I've also got a negative 24 to get negative 27 as the answer to that conditional equation. How many of g equals negative 27? Questions on that one? All right, number 12. I do have a little bit of combining I can do here. Number 12, what do I combine on the right hand, or excuse me, let's start on the left hand side. Kendall?
The 4 and negative.
To get,
Positive 8.
and then on the right hand side, I can combine the,
The 8r and negative 3r.
to get,
Positive 5r.
and of course the positive 2. And once we've done all that combining, right, we want to get rid of the little r, but thoughts, Kendall?
They're the same.
They're the same, so they're just going to cancel. And I'm left with a statement that says 3 equals 2. Well, the left may have you to believe that, but it's not true, class. This is a contradiction, and the answer should be no solution. Number 16. All right, there's a whole lot of combining we can do here. Number 16 on the left, what can we combine here, Brandon?
The 27y and the 10y.
To get
37y.
37y. I can also combine the
Negative 13 and 5.
to get,
Negative 8.
all right, and then on the right-hand side, Abby, I can combine
42y, negative 5y.
to just get
Sorry, I went blank.
42 negative 5?
37y.
37y. And then I can also combine the
7 and negative 15.
to get
Negative 8.
negative 8. And when I go get rid of the little y, once again, it's a tie. So class, what do I do with the 37y's? Cancel. And I love the statement that says negative 8 equals negative 8, which is always true, unless I decide to cancel them too, in which case the statement now says 0 equals 0. Either way, it's always true, class. This is an identity. The answer should be
S equals
Y equals all real numbers.
all real numbers. In this case, y equals all real numbers. Good job, Michael. Michael sits there smugly. Y equals all real numbers is correct. Questions on this? And I'm sowing strife. All right. Sibling rivalry. I love it. I love it. All right. Questions on this? Anyone go 4 for 4 this time? All right. Good. Go back and do all the odds now. 1 through 17, the odds. Feel like we've got the hang of it? Let's make sure we do, as we do numbers 1 through 17. The odd. Tell you what, I don't do candy in here often. So first one with all the correct answers gets candy. So once you're done with all, 9 of these, once you're done with all 9 of these, put your pencil down, look this way so I know that you're finished. We'll keep track of who finishes first, second, third. And the first one of you with all right answers will get some candy. Since clearly I am not concerned about your health. Actually, I saw this, it's a bumper sticker for Golden Donut, and it said, donuts are good for your health, your emotional health. And I'm like, that's true. It's all a matter of perspective, isn't it? So I was healthy and bought a dozen donuts right then. Sorry, Gavin. It's one of the great scourges of being in Japan. No golden donut. I'm sure they have other cool things in Japan, though. Maybe you can email me what some of those cool things are, if I can understand any of what it says. Brecken can still get golden donuts. I think they sell gift cards there to Golden Donut as well that could be given away as gifts to math teachers and such, too, by the way. Just thought I'd throw that out there. In case any of you were
For an
scratching your head.
improvement on the exam grade?
What?
For an improvement on the exam grade?
You're like, man, what can I give him? I love my math teacher so much. Golden Donut gift card. See? Try to help you out. Make this a conditional equation. Exam grade equals earned grade plus 10 minus Golden Donut gift card. Does that sound good? Okay, just kidding. I can't give you 10 bonus points just for a gift card. This is Brandon over here be like, oh, I got it for 5 cents. Yeah, that no.
How about 1 bonus point for every $10?
That's tempting. It's tempting. How about if everybody makes an A, I just pay for Golden Donuts and you guys get to eat them?
Yes.
Sorry, Gavin and Brecken, you don't count toward that. We do love you, but not enough to deliver you Golden Donuts. But I hope you make an A. Not enough to give you a donut. Michael's first. Abby second. Raven's third. One more minute. Genesis finished fourth. All right, put your pencils down. Let's see how we did. Check the answers you got done. We have 4 people in the running for the candy, but Michael gets first crack at it. Michael, your answer to number 1.
X equals 9.
Good, and so it is a
Conditional.
good. X is 9, it's conditional. Number 3.
Y equals negative 56.
And therefore,
Conditional.
good. Y equals negative 56. It's a conditional equation. Number 5.
M equals negative 14.
And also,
Conditional.
a lot of conditionals here. M equals negative 14. Number 7.
U equals all real numbers. Identity.
Uh-oh. All right. So on number 7, we go over to Abby, who finished second. What did you, well, let's ask you first. Are you good on 1, 3, and 5?
No.
No. All right, we go to Brandon. Are you good on 1, 3, and 5? All right, what did you get for number 7?
U equals 1.
Should be U equals 1, and therefore it is a
Conditional.
conditional equation. I am wondering, Michael, if somehow you were looking at number 9.
No, I interpreted it as it equaled all real numbers.
Okay. Well, we'll tell you what, we'll take a look at it in a minute. Let's finish going through the answers and see if Brandon gets candy. What is number 9?
X equals all real numbers.
All real numbers, because it's an identity. Number 11,
No solution.
because it's a
Contradiction.
contradiction. No solution. Number 13.
I thought 17 over 5 equals C.
All right, that is not correct. We go to Genesis. Are you perfect? You are not. Candy off the table. Let's go to Abby for this one. What did you get for number 13?
C equals 2.
It should be C equals 2. It's a conditional equation. Number 15, let's go back to Michael.
Y equals all real numbers.
Y equals all real numbers. It is an
Identity.
identity. Number 17, Genesis. What did you get? It is not 3. Brandon?
I think I did this wrong.
Number 17?
I got no solution.
It is no solution. It is a contradiction. All right, let's go through these here. Does anyone need to see number... Actually, we don't really have time to work out these. I do want to look real quick at number 7 because I knew that was the first one we missed. We have a negative 4u plus 12 equals 7u plus 1. We've got to bring the negative 4 over. That's the little one to get positive 4u. That gives me an 11u. And I'm going to send the 1 over to the other side to get it away from that u as a negative 1 to get 11. When we divide away the 11, 11 divided by 11 equals 1. And that should have been our answer there. Had some issue on number 13. Distribute the negative 2 to get negative 2c positive 2 equals 12c negative 26. Again, this is the little c. Move it as a positive 2c to get 14c. Bring the 26 over as a positive 26 to get 28. And that's where we get 2 equals c, or c equals 2. If you have other questions, maybe look at those in our next lesson. For homework this evening, you're going to complete numbers 1 through 21, the odd, on a handout. YouTube, as usual, handouts are going to be in the description of the video. This is not what I meant to grab. I thought that seemed like an awfully big stack of handouts. I think it's Pastor Hunt's notes. All right. I'll have to return those to him. All right, so a handout for you to complete. You're going to do 1 through 21, the odd. 1 through 21, the odd, on the handout. Quick note, don't lose the handout. We're going to spend the next 3 lessons periodically working a little bit on here. Okay, so this is not a one and done handout. We're going to use it for a little while, so put it somewhere safe. 1 through 21, the odd on the handout. Have a wonderful rest of your day. Have a wonderful weekend. You are dismissed.